heat is generated partially because it is not converted into completely carbon dioxide, and H2O is also converted into hydrogen component. So the heat is released is relatively less than complete combustion. We understand that. And then some part of the heat is also required to sustain this combustion. Okay, and remaining gas is coming out from the system at a relatively high temperature. So this is the description of gasification process. Obviously, the reaction temperature in this condition will be slightly lower than complete gasification. Okay, so when the reaction temperature are lower, then the chances of high hydrocarbons, that is called tar formation, is increased. Okay, so this is problematic. We want to filter it. Now, what is going on in plasma gasification that is also suitable for RDF and municipal solid waste? In basically here, the oxygen supply is almost nil and external heat is supplied to the system, and therefore the most of the part of carbon monoxide is very high, H2O is very high, oxygen is almost eliminated, and H2O part is and carbon dioxide part is very small. Unfortunately, this demand very high heat supply, and that warrant cost, electric cost. The temperature is very high. In very high temperature, the tar component and also the methane component is also at high temperature vanish. Very clean gas we will get. Unfortunately, the cost is high, and the cost of electrodes, these plasma assisted electrodes, is very high, and they are consuming during the process. So it demands frequent replacement. Another option may be a hybrid gasification. Hybrid means the conventional biomass feedstock plus municipal solid waste or refuse derived fuel can be used. This municipal solid waste is segregated, separated, recycled. You can see in this photograph. It is crushed and converted into powder form, and this powder form is poured here from this, and it is pressed, and briquettes or pellets are formed, and these pellets can be used along with biomass feedstock. So this is the biomass feedstock, and these are the RDF pellets. But how much it should be? How much it should be proportionate if I use all RDF, or we have to use complete biomass feedstock? So how we have to integrate it, it is a question, and it will depend on the chemical characteristic of RDF and biomass as well. So in this process, again, because the RDF is a low calorific value feedstock as compared to wood, so again the temperature will be, reaction temperature in gasifier will be lower, and the chances of the high hydrocarbons are again higher, and the chances of dioxin and furans may be again higher. Now we have to look at a Timarpur plant, which is a pilot research and development plant for thermal treatment of 300 ton per day of waste with 3.75 megawatt power generation capacity. It was installed in 1987. The plant was on trial and was operated for few months, subsequently closed down in 1990 due to mismatch of the quality of incoming refuse or waste, as that quality of or the calorific value of the feedstock, that is waste, was relatively low, at low as compared to the design point of the plant. So finally, the plant could not survive and it is failed. So when this plant was failed, it is very important for us to proceed further when we are talking about municipal solid waste. So why should not the physical, the characterization of municipal solid waste is carried out prior to utilization of this municipal solid waste or RDF along with the biomass. So what we have done, basically these are the equipments which needs to perform this duty. What we have done to collect the sample from the landfill site, we have divided into seasons. The season 1 is in between 16 December, and because the experiment was carried out in 2008 and 2009, so from 16 December to 30 March, season 1, season 2, 1st April to 30th June, season 3, 1st July to 30th September, and season 4, 1st October to 15th December. So these samples were collected accordingly, and for entire process for this work, the 300 samples were collected. Basically, this is, I forget actually to introduce this. This work is carried out by my PhD student, Professor Rajkumar Singh from DTU itself. So I am sharing their work with you of this PhD work. Okay. So this is the duration of that PhD, and this was divided into the 4 sessions to comparative analysis. Collection of samples, there is a set standard procedure for collection of sample of municipal solid waste. So it is a dalao situated in different type of area, that is residential, slum, commercial and industrial were identified. Trucks coming from there are also identified at landfill site. The sample were also collected from the dalaos. The 10 kilograms of sample of municipal solid waste were collected from 10 different points from outside and inside of the solid waste heap. Similar exercise were carried out at 5 different dalaos or truck leading to landfill sites. Around 500 kilograms of municipal solid waste is mixed thoroughly to make one representative sample, and it is then reduced to around 100 kilograms by coining and quartering method. 5 represented samples were collected from municipal solid waste, leading to each landfill site for one season. 15 samples were collected from different representative profile of municipal solid waste, 5 each for 3 landfill sites per season. Thus, 60 samples were collected for final characterization. Sample size reduction using the method coning and quartering techniques. So it is followed, and surplus to quarter from the last size reduction should be retained for analysis of moisture content and bulk density. The physical characterization of municipal solid waste, the waste component that may be categorized into A, B, C, D, and E. A for fuel component, B organic component, C inert, D recyclable, and remaining miscellaneous. In fuel, wooden pieces, paper, cardboard, textile, cotton, coconut shell, polythene bags, school bags, plastics, straw and hay, thermocols, and dry leaf or dry matter. And similarly, the green matter, leaves cutting from tree, vegetable peels, and kitchen waste, vegetables. Inert, concrete, stone, ceramics, lime, mud, soil, brick, broken tiles, etc. recyclables, sorry, glass, rubber, metal, miscellaneous, hazardous waste, medical waste, moist, and muddy vegetable waste. These are basically categorized, and all these fuel, organic, inert, recyclables, miscellaneous for different season for Ghazipur land soil is collected, and this is tabulated in weight percentage basis for each sessions, each seasons. Similarly, Okla landfill, we can say all the components are collected for different seasons for comparative analysis. From Balaswa landfill site, the data is collected in this form. It was observed in season 3. The organic component is very high. So that is depend on the pattern in a particular period. It will depend on so many things, location, and it will vary. But not much. It is a consolidated table for season 1 and season 2 for Ghazipur, Okla, and Balaswa. So all pieces are, more details are represented in this table. And after this, thermochemical characterization is carried out. The chemical characterization, the one part is also included, that is moisture content. The sample was kept at electric oven, maintaining at constant हेलो हेलो
यस सर।
आवाज आ रही है सर? बीच में
हाँ
डिस्टर्ब
सर,
हो गया कुछ?
नहीं आवाज आ रही है अभी तो।
अच्छा, ये विजुअलाइज हो रहा है?
हाँ, थर्मोकेमिकल
जी
कैरेक्टराइजेशन।
जी जी जी, ठीक है, ठीक है, थैंक यू। अगर कोई दिक्कत हो मुझे प्लीज कन्वे कर दीजिएगा। आप, कई बार ऐसा लगता है कि शायद कनेक्शन कुछ
नहीं
पुअर है।
दिक्कत होगी, हम आपको कॉल कर लेंगे।
जी, थैंक यू। So we obtain the moisture content of the feedstock. For measurement of ash, the temperature of muffle furnace and crucible was gradually increased to 950 degrees centigrade for more than 2 hours till the weight become constant, which is recorded. The weight of residue represent the ash content. The volatile matter was obtained from dried sample, keeping at 950 degrees centigrade for 6 minutes. The difference in weight gives the volatile matters. Because the volatile matter is a time dependent process. So we take certain time where at a particular temperature it is quickly released. So we not need to wait for more time. 6 minutes is enough. Proximate analysis of municipal solid waste and RDF was also carried out. It provides the information of moisture content, fixed carbon, volatile matters, and residual ash. Proximate analysis of municipal solid waste. The moisture was observed for, this is basically for RDF basically. It is for municipal solid waste, sorry. The moisture content was 60%, 40%. Ash was 25.1%, which is very higher side. For conventional gasification, so the feedstock, biomass feedstock, it should be at the most 5%. The volatile matter, that is about 32%, fixed carbon 3%. The calorific value of mixture is recorded 4.9 or at the most 5 megajoule per kg. And the analysis of carbon, hydrogen, nitrogen, and sulfur is also carried out. And the average was calculated, this one. The RDF was prepared manually by discarding materials such as sand, dust, concrete, stone, and exposing to oven for moisture removal. It is reduced to half kg by method of quartering. It is a well-known method of quartering of collecting the samples. It is the segregated municipal solid waste, which is converted, which is crushed into powder form, and it is called RDF. If we compress it into briquette form or pellet form, so it is called RDF pellets. So the chemical or the proximate analysis of RDF was carried out. The moisture content was released, is very small relatively. It is only 16%, ash content 20%. It is again higher, but it is relatively less than municipal solid waste. Volatile matter is considerably high, and fixed carbon is also very good. And it constitutes the calorific value of RDF, that is 10.88. It is very, very good. The ultimate analysis of carbon, hydrogen, nitrogen, and sulfur is carried out, and for different samples. Heating values are obtained using different tests, and the bomb calorimeter is used, the precision was used, and the low heating value is used basically for calculating the efficiency, thermal conversion efficiency. So it can be derived from higher heating value in terms of what is the moisture and what is the hydrogen component on this basis. Thermochemical characterization, the total of the three samples, Gazipur, Okla, and Balaswa, roundabout, you can see the ash content, that is important part, 25.4, 24.7, almost same, but it is slightly on higher side. This is very important, very critical when we are running the gasifier. So we have to link it to gasifier operation when we are going through the characterization of this. So again, other tests were carried out for calorific value, bulk density, moisture content. Next is TGA, thermogravimetric analysis. TGA and DG thermograms for RDF sample were obtained using a model, that is Perkin-Elmer, and that is very used for recording the weight loss as a function of time and temperature, and for a specified heating rate and flow rate of sweeping air. Experiments are accordingly carried out as per the standards, and the results are here. It is TGA diagram, or it is 100% weight percentage. No, this is the sample was, and it is the temperature. So when we put the sample and start increasing the temperature, so slowly the moisture is driven out, and slightly some weight loss is observed. And when the temperature become more than 200 degrees centigrade, or in between 200 to 300, so the pyrolysis process will start. And in pyrolysis process, the char is produced and volatile matter released from the feedstock. And about 450 at the most, this process will be over. Okay, and then if we that is coming out of the sample is observed here. So it will provide us the entire idea of what is the rate of release of volatile, what is the rate of char formation, what is the rate of char conversion into gas, and the ashes residue. So it will provide the so many informations that are useful. These informations may be useful to derive the chemical reaction rates also. This test was carried out basically in air, and in air when the temperature is higher, so some chemical reaction will take place, oxidation reactions will take place, and the temperatures are relatively higher. Here the test was carried out in nitrogen. In nitrogen, this chemical reaction rates, and that is oxidation, will completely eliminate it, and it is inert environment basically. So both of them can decide what is the how we quantify the how much oxidation reaction is taking place at these temperatures. Ash characterization is very important. What we are discussing, the how much ash content are there, and how much the characteristic influence the gasification process is important. Ash deformation and diffusion temperature can be used as indicator of sintering and deposition tendency of ash that may hamper the process orientation. What happens? So the ash has certain deformation temperature and fusion temperature. When the gasification process is proceeding, so the temperature increases and it may reach up to the ash deformation or ash fusion temperature. So what happens then? The ash will convert into a molten material, and when it is after certain duration, it become a very clinker, very hard stone-like structure that will deposit over the grate of the gasifier and obstruct the operation. So we need to very careful select the biomass material as a feedstock which has the ash deformation and fusion temperature just above the gasification reaction temperatures. So these tests are carried out. The sample was obtained. The ASTM method is used for measuring the ash deformation. A solution of 10% dextrine and 0.1 salicylic acid and water 89.9% by weight was mixed in ash and prepare a stiff paste of small cone-like shape, and it was slowly heated and observe the tip of this cone. When the tip is started melting or it become round, so this temperature is called ash deformation temperature. And when this ash, when further increasing the temperature, we observed that the ash become fused, become just like a liquid paste and become round. So this temperature is called fusion temperature. These two temperatures are very important. So we need to ash fusion temperature of RDF. Initial deformation temperature when the tip was started, that is 860 degrees centigrade. Softening or hemispherical, when it is the cone is converted into hemispherical shape, so the temperature become 950. And when it becomes just like a fluid, so it is around 1100 degrees centigrade. Other the silica, alumina, and present in the ash that has been quantified here from these tests. More tests are also carried out. The quality of uh, SEM images of, and one more EDS analysis, that may uh, different now there is a cooling cleaning system. We can also see what is the standard that is important. The particulate content should be less than 50 milligram per meter cube at normal condition, and tar content should be in this less than 100 milligram per meter cube at normal condition. And these conditions are basically for IC engine, because we have the experience of IC engine only. For gas turbine, these conditions are more stringent, basically. So different kind of cooling cleaning systems, subsystems are used. Induction system is also required to connect with the gasifier to a engine, and because here the engine carburetor is meant for a chemical reaction or stoichiometric ratio, different stoichiometric ratio of air and fuel, and the producer gas stoichiometric ratio is different, and for natural gas it is 17.1, and for producer gas it is 1.3:1. And what about for diesel and petrol? You know very well, 15 point and 14.5, like that. The objective of this is to prepare or mix good quality mixing and uh, low pressure drop. These two requirements should be meet. This mm, this carburetor, gas carburetor, is designed by my MTech student through CFD analysis. The gas engine can be modified in dual fuel mode. Minor modifications are required, and it demands low engine speed with increased ignition advance and insufficient penetration and overheating of nozzle due to low flow rate, because when we are using pilot fuel, so low flow rate or other serious problem associated with dual fueling. For example, dribbling. The fuel dribbling is also one of the problem. In single fuel mode, we need drastic modification, insertion of spark plug if we are converting from diesel engine, or if we are converting a gas engine in single fuel mode from a spark engine itself. So we not need to apply this, but we need to control the compression ratio in that case. So whether the existing engine is diesel or petrol doesn't matter. We need to control the compression ratio and the spark timing at least. Okay. Utilization of low calorific value is in converted engines result power derating, power loss. Sometime it is observed more significant in single fuel mode. In dual fuel mode, it is the impact is very small, but here it is very high. Another aspect is that the dependency of engine on fossil fuel, that is diesel, pilot diesel, can be reduced by using the biodiesel. Biodiesel blends, 20% is very safe blend that can be used. And single fuel mode is completely free from the fossil fuel. Only for starting, certain fuel is required, that is petrol fuel is required, and thereafter it is self-sustaining process. It is a complete system. It is the performance. You can see the performance of it is a diesel engine. It is a diesel engine, and it is a dual fuel engine. So it is it is also observed that the thermal efficiency sometimes is better than the single fill mode. But it's very rare. If everything is perfect, then sometimes it is observable. It is the diesel replacement. The diesel replacement here in this case is in between 70% to 80%. If we include the biodiesel itself here, so this percentage will be much higher. That means we can say the diesel replacement. A 10 kilowatt downdraft gasifier was used for blending of RDF in briquette form plus biomass feedstock. These are the description. A experimental model was developed by research scholar at that time, and that was very compatible. This is a special kind of carburetor system, and that was designed in ISC Bangalore, basically, net Prof. And from here, the air and gas is mixed together and passes through the engine, converted engine. And there is a safety device is attached in case of backfire. So it will be released from the here by tearing this blocking stage. Now, experiments were also carried out to observe the emissions from the system, carbon monoxide at different power ratings. So it was observed the pollutant per kilowatt, carbon monoxide, hydrocarbons, carbon dioxide and NOx emissions at different power rating were observed, and average was also taken care of. Different systems are used. 10 kilowatt engine was used. It was 3-cylinder situated in IIT Delhi, Mechanical Engineering Department. The experiment was carried out again to the cooling cleaning system. Okay, what is the pH value of the what is the total dissolved amount in water which is circulating through the BOD 3 days at 27 degrees centigrade. So cyanides, dissolved phosphate, and this is the standard of CPCB, and this was observed or measured from this experiment and very close. It is slightly higher side, but it is free ammonia is also on higher side and beyond this, and it is minorly almost. So this was the emissions and the effluent during the cooling cleaning system. A model of a landfill, that is land jam, is used to model the methane and carbon dioxide emissions from the landfill site, and it will allow us to ensure that if we install such type of gasification system which is processing the municipal solid waste or RDF, and if we apply, so what will be the impact on the emissions, methane emissions, carbon dioxide emissions, total gas. So that was keeping in mind, and the two cases were considered for comparing using this land jam model. The case one is when the municipal solid waste is being dumped at landfill site till year 2020, because the study was carried out relatively earlier. So it was presumed that up to 2020, if the municipal cell, instead of getting dumped into landfill site, is utilized in gasifier engine system from 2012 onwards to produce electric power. So what will be the difference if we want to see the impact of this study? So we will observe that this is landfill gas, any total landfill gas that is liberated or that is coming out from the landfill, and it is the year from where it start reducing, 2012 around. And methane component, And if we installed the system where we started the gasifier, so this will be only the total gas liberated will be here itself, round about here. So this emission of the gases are relatively less because of the gasification technology. These emissions, the saving of emissions through waste to energy technology, we can compare here itself more clearly. It is the case one when there is no gasification system. When gasification system is installed, so it's quickly trying to reduce, and so on. If there is no gasification system, so this curve will be higher, higher and higher. NMOC, that is non-methane like component emission. So one category is methane like component or methane liberation or emissions, another than methane. So the effect you can see here. Carbon dioxide equivalent saving. This is the category. I think conclusions I need to do. Municipal solid waste quantity is increasing at alarming rate and degrading the environment seriously worldwide. Plasma assisted RDF municipal solid waste conversion technology can treat a large number of waste in safe and reliable manner. It provides energy rich gas followed by material recovery at extremely low emission level. Unfortunately, it consumes high power to create plasma arc, so the costly. Raw municipal solid waste can upgrade to energy rich RDF by sorting, segregating of inert, recyclables, and non combustibles. From experimental experience, RDF is observed to be the rich fuel for gasification with conventional biomass feedstock. However, their proportion need careful consideration in gasifiers. The initial deformation and softening temperature of ash from RDF is observed to be lower than wood. So this is welcome. Considering emission reduction in terms of equivalent carbon dioxide, that is a global warming gas, greenhouse gas for each year, and due to production of electricity from RDF, the saving of methane and overall saving of emission in terms of equivalent carbon dioxide for next 20 years, that will start from 2012 almost, would be 1929662 megagram. The concentrated efforts are needed in cutting back on greenhouse gases emission as well as preparing for a changing world via adoption of such municipal solid waste conversion technology. Thank you very much. I would like to invite for any query.
Any queries from the participants? Please ask.
सर गुड इवनिंग सर.
Good evening.
हाँ सर, एक्चुअली ना सर मेरी एक प्रॉब्लम है सर. मैं आपसे क्वेश्चन है, मैं पूछना चाह रहा हूँ सर. डीजल इंजन में इंजेक्शन टाइमिंग हम सर कैसे उसको एडवांस करें या सर रिटार्ड करें सर, प्लीज सर.
देखो, डीजल इंजेक्शन को तो नहीं कर सकते हम. अगर हमारा सिंगल फ्यूल मोड है उसमें इंजेक्शन हम चेंज कर सकते हैं. डीजल इंजन में जो डीजल स्प्रे होता है दैट इज गाइड कंबशन, वो इग्नाइट करता है कंबशन को.
जी सर.
अगर वो नहीं होगा तो कंबशन नहीं होगा. प्रोड्यूसर गैस इज ए लीन गैस एंड लीन गैस कैन नॉट स्टार्ट. तो उसको इग्नाइट करने के लिए हमें मिनिमम क्वांटिटी ऑफ डीजल नीड्स टू बी स्प्रेड व्हेन इट इज कंप्रेस्ड. The mixture of producer gas and air when it is compressed, so we need to make a spray over it so that the ignition will take place. And it is a very
Okay.
minute quantity of gas. If we are using the 100% in diesel engine, so it is hardly 25, 20 or 15, or sometime it is 10% only. And
Okay.
if we add biodiesel in it, so again 20% of biodiesel can be substituted in diesel. So again there is a saving of diesel.
Okay, sir. Is there any minimum quantity of pilot diesel, sir?
Yeah, I have told you.
Recommended minimum
Yeah,
quantity of.
the 20%
Okay,
is
sir.
the approved quantity. And sometime it was observed that if the engine and gas quality is very good, sometime it is almost eliminated, or 5% or 10% only is required to be injected. Otherwise, producer gas can substitute all the energy except this. 95% substitution may be possible.
Okay, sir. Thank you very much, sir.
Ji.
Yes, any other, please? Yes, MSW's gasification is a very, very important area. We
Sir,
are
good evening,
a lot of problems.
Dr. Avdesh. I am Harijan Das. I have also worked in the waste to energy plant in Delhi, along with the Jindal.
Yeah.
Now, that was a complete incineration. Now, my question is, when you are talking about the landfill remediation, the whatever is the amount coming out from there, which could be reused. Do you find, apart from plastic, any other, the remnant can be reused for waste to energy, particularly for
Yeah.
pyrolysis, whatever you are telling, sir?
What I understand from your side, that the plastic can be reused in gasification. Yeah, right, sir?
No, yeah. Actually, the process of remediation is already there.
Yeah.
You are seeing that in Okla and other places, and Gazipur, and then this is already there. But the huge mass which is being excavated, what will be the reuse of that one, sir? Can you suggest something?
Yes, for my what I am observing, I have used the biomass plus RDF. RDF is nothing but municipal solid waste, and municipal
Sir.
solid waste contain plastic itself. The plastic, some people has done some experiment on gasification using some plastic waste, and they observed that the hydrogen component, that is the more important part of the producer gas, that is higher when the plastic was burned together with the biomass or any other waste. So these all plastic itself can do some chemical reactions. There are catalytic effect, I think, and that will convert in hydrogen into H2O into hydrogen itself. And hydrogen, because it is a high burning fuel, high speed burning fuel, so it can enhance the combustion speed, and therefore the
Okay.
and
Okay.
if the RPM is good and the hydrogen component is there, so again the thermal efficiency is higher.
Mm-hmm. Any plant installed in the country, sir? So far, PEG? Have you come
Any
across
plant?
any working plant is there in India for PEG?
Yeah, plant.
Yeah.
Yeah. There are a huge amount of plant are there in Rajasthan. In as if Bangalore has installed plant, that is Orcha place, and that was done, and that was a test plant. And there are so many plants are running in engineering colleges, in sugar plants. If you are observing the sugar plant, paper plant, some electricity is producing using this gasification technology, and sometimes they are using the boiler and steam generation plant using, and then followed by gasification plant. So nowadays this is very largely using. And what is happening at present in villages, basically this technology is basically dedicated for villages, but for municipal solid waste, which is in urban area in metropolitan cities, there is a huge problem. That is actually when we are converting a dedicated gasifier, that is biomass gasifier, to different low calorific value fuel. So again, the performance hampers definitely, but we need to mix, and we have to calculate some proportion of biomass as well as RDF or municipal solid waste can be used. The municipal solid waste, after converting into the RDF, that can be also processed through different gasification systems which are using in powdery form. For instance, in trained gasifier, bubbling gasifier. So there are scope of using without making any briquettes. When we have to use the briquettes, so we are talking about a solid gasifier system, solid biomass gasifier system. So we can see in that way.
Okay, sir. Thank you. Thank you, sir.
Thank you, sir.
Yes, how is it open? Anyone else? So we will take this opportunity. Anyone? Yes. So it was a very, very nice, excellent presentation based on MSW energy gasification. Yes, Jain sir, you're telling something? PK Jain. Okay, I think that was by error. So MSW is also a problem for our space, and we have to require a lot of landfill sites for disposal of waste. But if we are converting this for gasification, not only we are getting the energy, but we are getting the space also, and we are getting our MSW storage or problems solved. So with this, we thank Professor Avdesh Sharma. He is also a constant source of support and inspiration for us at DTU, and he is doing a nice work, experimental work at Deshbandhu Chopram Murthal University. So we thank him from the all organizing team as well as from the participants. Thank you, sir.
Thank you so much.